Okay, let us start today's lecture. हमने थ्योरम का स्टेटमेंट लिखा था। स्टेटमेंट आपने उसका लिखा है? हाँ,
Yes, sir.
ओके। प्रूफ वन implies टू। One implies two. So what's one? One S is a rectangular band. In two, every element of S is idempotent and ABC equal to AC. So suppose this S is a rectangular band. Rectangular band. We show that every element of S is idempotent and ABC equal to AC. So we show this. We show that A square equal to A and ABC is equal to AC for all A, B, C belongs to S. So it's given that A is equal to A for all A, B belongs to S, the rectangular band. So therefore this A, by putting B equal to A, it's equal to A, which is equal to AQ. It's equal to AQ. So A is equal to AQ. This gives A square is equal to A4. Also by putting this B equal to A square, we get, by putting B equal to A square, we get this. B का वैल्यू हम A square लेंगे इसमें, okay? B equal to A square, so we get this A equal to A square A, which is equal to A power 4. इसका नाम आप 1 रखिए. But what's A power 4? It is equal to A square by 1. So thus A square equal to A for all A belongs to A. इसको आप कॉपी कीजिए. हो गया ये?
Yes, sir.
ओके, मैं इसको इरेज कर सकता हूँ. 10 thus a square is equal to a for all what for all a belongs to S. अब हमें प्रूव करना है ए बी सी इज इक्वल टू ए सी. नाउ वी हैव, आपके पास पहले ये आइडेंटिटी है ए बी ए इज इक्वल टू ए, ये आपके पास गिवन आइडेंटिटी है. ओके, और यहाँ से आपको ये भी मिलेगा C इज इक्वल टू सी बी सी, है ना, बिकॉज इट्स ट्रू फॉर एनी एलिमेंट इन S. So A, B, C are elements in S, and you can say this B is equal to, तब यहाँ पर हम कोई भी एलिमेंट बीच में रख सकते हैं, B A C B, ए बी ए इज इक्वल टू ए, ये बी कोई भी एलिमेंट हम रख सकते हैं, ये आइडेंटिटी है. सो दिस बी इज इक्वल टू बी ए सी बी. ओके, B is equal to ABC. So thus we have this AC. What's AC? AC का value हम लेंगे. What's A? A is AB A, and what is C? C is CBC. And this one should be equal to ABC. ये ABC आना चाहिए ना, ABC. A तब बीच में एलिमेंट B आना चाहिए, हम इसको ऐसे लिख B AC B C. Okay, now this one B A C B, it's equal to B, it's just A B C. So thus A B C, this is very simple, आपको सिर्फ आइडेंटिटीज का ख्याल रखना है. A B C is equal to A C. So that proves one implies second. Okay.
Yes.
इसको इरेज करो मैं इस पेज को.
Yes, sir.
Now second implies third. So second means assume that A square is equal to A for all A belongs to S, and ABC is equal to AC for all A B C belongs to S. So assume second holds. We prove third, that means there exists a left zero semigroup L and a right zero semigroup R such that S is isomorphic to L cross R. So we define L and R.
सर आपकी आवाज नहीं आती है क्लियर.
So second implies third means we assume that every element of S is an idempotent. So that's A square equal to A for all A in S, and it satisfies this identity also. ABC is equal to AC for all ABC belongs to S. So we show that there exists a left zero semigroup and a right zero semigroup R such that S is isomorphic to L cross R. So let's choose an element C in S. Let's C belongs to S. Okay, C belongs to S. C belongs to S, and let's define, let L is equal to SC, which is equal to these elements as this set S belongs to S, and define R, which is equal to, which says CS. Okay, we define R that CS is this set S belongs to S. We show that this L is a left zero semigroup and R is a right zero semigroup, and finally we will see that our semigroup S is isomorphic to L cross R. Okay, so left zero semigroup means that every element is left zero. Every element left zero means that if we choose any two elements, say A and B in L, we need to show that our AB is equal to A for all AB in that semigroup, तब जाके वो लेफ्ट जीरो सेमीग्रुप बन जाएगा. तो लेफ्ट जीरो की प्रॉपर्टी क्या है? लेफ्ट जीरो हम एलिमेंट ए को कहेंगे ये लेफ्ट जीरो है अगर ए बी ए के बराबर होगा, मतलब ए एक्ट करेगा जीरो ऑन लेफ्ट साइड. जीरो का मतलब क्या है? इसको किसी के एलिमेंट के साथ प्रोडक्ट कीजिए, वो एलिमेंट यही आ जाएगा जीरो की प्रॉपर्टी. सो लेफ्ट साइड, लेफ्ट जीरो मीन्स लेफ्ट जीरो सेमीग्रुप मीन्स इसका हर कोई एलिमेंट लेफ्ट जीरो होगा. So that means if we choose any element A in L, we need to show that A is its left zero. So that means AB should be equal to A for all B belongs to that L. Okay. So now let A comma B belongs to L. Suppose these are two elements, and we will show that AB is equal to A. So this A is in L, but what's L? L is SC. So that means there exist two elements, say S and T in S, such that this A is equal to SC and B is equal to TC. Okay, that's the definition of L. Now let's find the product. Now what's AB? Now this AB, A is SC and TC. It's given that the product of three elements A, B, C is equal to the product of last two elements. Here it's given. So here I will write it as this is equal to this one. It's equal to S CT and C here. So this is the product of three elements. First element is S, second element is CT, and the third element is C. So it's equal to the product of last two elements SC. But what is SC? SC is B. So thus AB, SC is, sorry, it's A. SC is A. So thus AB is equal to A, and therefore L is a left zero semigroup, and therefore L is a left zero semigroup. Therefore L is a left zero semigroup.
तो मतलब दो एलिमेंट्स हम जो हम ऑपरेट करेंगे लेफ्ट साइड से, तो जो रिजल्टेंट आएगा वो आएगा राइट वाला एलिमेंट,
लेफ्ट वाला आना चाहिए. ए बी इक्वल टू ए, राइट जीरो के लिए राइट वाला आना चाहिए. ए बी इक्वल टू बी आना चाहिए. ओके, जैसे ना लेफ्ट आइडेंटिटी का मतलब क्या है? ई ए इज इक्वल टू ई फॉर ऑल ए इन द सेट, तब जाके ई को कहेंगे लेफ्ट आइडेंटिटी. अब जीरो का मतलब, जीरो की डेफिनेशन ये है ना, जीरो ए इज इक्वल टू जीरो इज इक्वल टू ए जीरो, ये जीरो की प्रॉपर्टी. अब लेफ्ट जीरो का मतलब ये है कि जीरो इंटू ए इज इक्वल टू जीरो, लेफ्ट जीरो. तो आपको प्रूव करना इसका हर कोई एलिमेंट लेफ्ट जीरो होना चाहिए. मतलब आपको प्रूव करना ए बी इज इक्वल टू ए फॉर ऑल ए बी इन एस, फॉर ऑल ए बी इन दैट दैट सेट जो आपके पास है, दैट सेमी ग्रुप एल, ये आपको चेक करना है. So thus AB is equal to A, and therefore L is the left zero semigroup. इसको मैं इरेज करूँ इस पेज को. Okay. And therefore L is a left zero semigroup. So now let's take two elements from. Now let AB belongs to R. Then there exists C belongs to, sorry, not C. There exists S and T. Okay, there exists S, T in S such that A is equal to, what's your R? R किसके बराबर है? CS है. CS है. CS, and this is your A. This is A. Need to write CS, and B is equal to CT. This is equal to here. Now AB is equal to CS into CT, and that's equal to C times CS into CT. Okay, CS into CT, and that's equal to C times SC T, and this is the product of last two elements, that's CT, which is equal to B. So thus AB is equal to B, and therefore this R is a right zero semigroup. R is a right zero semigroup. R is a right zero semigroup. So now we see that our S is isomorphic to L cross R. S is isomorphic to L cross R. S is now we show that S is isomorphic to L cross R. So for this we define a map from S to L cross R. Define a map phi from S to L cross R by S phi is equal to element of L, that's of the type of SC, and element of R is the type of C into element of S, CS will. Okay, so this is well defined. If I choose say S equal to T, this phi is well defined. It's very simple. Okay, it's well defined. So let's choose elements S and T in S such that S is equal to T, which means that SC is equal to TC and CS is equal to CT. So therefore SC CS is same as TC and CT, which implies S phi is equal to T phi. So if the elements are equal, then their images are also equal. Next, phi is morphism. Phi is morphism. Phi is a morphism. Let's choose two elements. Let ST belongs to S. Now we have this ST. Phi is equal to, what's the definition of this? It is SC. So S की जगह पर ST है, STC and C ST. Okay, and और आप इसको ऐसे ही लिख सकते हो, इट्स STC CST. Now this and this one S phi T phi is equal to SC then CS, its product with what, T phi, what's that, TC and CT. Here they are both semigroups L and R, so the product in L cross R is the component wise. It's equal to SCTC, and this one is equal to CS CT, CSCT. अब ये आना चाहिए STC के बराबर है, STC. That's there, because you can treat this as one element, C as the second element and TC as the third element. So the product of three elements is equal to the product of last two elements. So last two elements are the S and TC. और ये दूसरा वाला आना चाहिए CST. So this you can treat as a single element, C, S as a middle element and this CT as the third element. So this is equal to STC. And second one, this is equal to okay SC. Okay, this is CS, CS as the first element, then C as the second element and T as the last element, third element. It is CST. CST. That's equal to ST phi. That's equal to, वो मैं यहाँ नीचे लिख देता हूँ, that's equal to ST phi. अगर आप इसका नाम रखोगे कि कुछ ऐसे 1 by 1 by, it proves the morphism property. ST phi is equal to S phi T phi. So this phi is a morphism. Now we check this phi is 1 1 is injective. Phi is injective. Phi is injective. Okay. phi is injective. So let S T belongs to S such that एस पी इज इक्वल टू टी पी. आपको प्रूव करना है एस टी के बराबर है. एस किसके बराबर आना चाहिए? टी के बराबर. सो दिस गिव्स व्हाट्स एस पी? इट्स एस सी सी एस इक्वल टू दिस वन इज टी सी and this is CT, TCCT, which gives SC is equal to TC and CS is equal to CT. आपको प्रूव करना है ST के बराबर आना चाहिए. आपको S से स्टार्ट करना है. S. Now what's S? S is same as S square because अभी हमने आइडेम्पोटेंट प्रॉपर्टी का यूज़ नहीं किया है ना. हर कोई एलिमेंट आइडेम्पोटेंट है. सो एस इज सेम एज एस स्क्वायर. अब हम एस स्क्वायर के बीच में कुछ भी रख सकते हैं ना. एनी एलिमेंट यू कैन इंसर्ट. सो आई विल डू दिस एस सी एस इज एस इंटू एस स्क्वायर. मुझे किसी तरह से टी मिलना चाहिए. अब यहाँ पर देखिए एस सी का वैल्यू है टी सी है ना. इट्स इक्वल टू टी सी एस. नाउ व्हाट सी एस? दिस सी एस इज सी टी. सो दिस इज टी सी टी which again because ABC equal to AC, so it's equal to T square. Again T square is T because every element is idempotent. So S is equal to T. S is equal to T. Therefore this phi is injective. It is injective. अब इसकी लास्ट प्रॉपर्टी ऑन टू सर्जेक्टिव. He is surjective. He is surjective. तो सर्जेक्ट के लिए आपको L क्रॉस R से कोई भी एलिमेंट लेना है. आपको इसकी प्रीइमेज चाहिए. So let's choose any element in L cross R. So what's L cross R? Let Y belongs to L cross R. Okay. What's L? L means SC. Okay. Cross CS. So that means this Y is of this type. The element of L means it's SC and element of T means it is C into element of S. That may be different. बट वी नीड टू शो दैट दिस टी शुड बी इक्वल टू एस. क्योंकि अगर टी एस के बराबर आ जाएगा ना, ये फिर एस फी के बराबर आ जाएगी. मतलब फिर वाई की प्री इमेज एस आ जाएगी. बट इन जनरल बिकॉज इट इज़ एन एलिमेंट ऑफ एल क्रॉस आर, सो इट मे बी डिफरेंट है. सो दिस एल इज एस सी. इसका हर कोई एलिमेंट क्या है? एलिमेंट ऑफ एस इंटू टी. इट इज सी एस. इसका भी हर कोई एलिमेंट क्या है? सी इंटू एलिमेंट ऑफ एस. तो ये एस और टी डिफरेंट हो सकती है. और हमें ये चेक करना, ये इंश्योर करना है कि ये यहाँ पर सेम है. एक्चुअली टी एस के ही बराबर है. टी इज इक्वल टू एस. तो वो हम कैसे करें? We have हम इस एलिमेंट से स्टार्ट करेंगे है SC it should be image of some element. Okay, but this SC is same as it's same as S. I can insert any element here in between S and C. So let's choose some suitable element. Let's choose here T. Okay, let's choose T here, TC, and here I can choose any element between C and T. So let's choose S. Let's choose as T. आपको ये समझ आ रहा? This is the product of three elements. It's equal to the product of last two elements, and this is also the product of three elements. It's equal to the product of last two elements C and T. But then this one, it's equal to, इसको मैं ऐसे अब लिखूंगा, it's equal to STC, and this one, it's equal to CST. Okay, it is CST. It is CST, and this is equal to the image of this element ST, image of ST under phi, by definition of phi. So that means for any y in L cross R, I have an element ST which is in S such that image of that ST is equal to y. Y means SCCT. तो इसकी इमेज आपको मिल गई, इसकी प्री इमेज आपको मिल गई, इसकी आपको प्री इमेज मिल गई. So therefore this phi is also surjective. Phi is surjective. So hence phi is an isomorphism, and therefore therefore we have this S is isomorphic to L cross R. S is isomorphic to L cross R. This is second implies third. Now we have third implies fourth. So suppose we have a left zero semigroup and a right zero semigroup such that S is isomorphic to their cross product. Let third is given, let L be a left zero semigroup and R be a right zero semigroup such that S is isomorphic to L cross R. S is isomorphic to L cross R. आपको 4 चाहिए, you want 4. Okay, okay, let us choose this L equal to A and R equal to B. So okay, we will can choose L equal to A and R equal to B. हम L को A choose करें और R को B choose करें, and then S is isomorphic to A cross B, and we will see that the product in A cross B, S should be isomorphic to A cross B where A and B are non-empty sets. यहाँ पर ये left zero right zero semigroup से they are also non-empty sets. और फिर हम प्रूव करेंगे ये जो प्रोडक्ट है ना ए क्रॉस बी में, वो इस प्रॉपर्टी को सेटिस्फाई करेगा, फोर्थ प्रॉपर्टी को। चूज दिस ए इक्वल टू एल एंड बी इक्वल टू आर, ओके। Then S is isomorphic to A cross B. तो आपके पास दो सेट्स है ए और बी, साइज S is isomorphic to A cross B। अब आपको सिर्फ चेक करना है ए क्रॉस बी में आपको दो एलिमेंट्स